All right, folks, moving on to section 5.1, bisectors of triangles. So again, we start with some theorems to get us going here, to make sure we're understanding what we're doing here. So perpendicular bisector theorem. If a point is on the perpendicular bisector, so again, here's your perpendicular bisectors right here. Cuts that into the equal parts. So CD is your perpendicular bisector. Then we can conclude that AC right here equals BC. And the same thing in reverse. If they give you AE is equal to BE, then we can conclude that we have a perpendicular bisector from there. So with that in mind, then we go to an example where we can solve or get an answer. So it says find BC. Here's BC. So we have that this right here is a perpendicular bisector, so this equals that. Final answer is 8.5. This one right here where it says find PQ, so find PQ, we want to know what this is here. Well, again, here's your perpendicular bisector, this line right here. So now we set this equal to that. Set those two equal to each other right here. You solve for x, x is 2. Plug it in for PQ, and you find that your final answer is 7. Final answer is 7. Next slide, same concept, find EH. They want you to find EH. This is a perpendicular bisector, so you set these two equal to each other. 5x minus 20 equals 3x minus 4. 2x is, add that over, we get 16. X equals 8, and then you have to plug it in. And 5, so 5 times 8 minus 20, 40 minus 20, final answer is D, 20. Next slide here is called the circumcenter, is the location, and really what we want to think about is, even though that is a true statement here, we want to know that that's where the perpendicular bisectors intersect. So if you hear circumcenter, we want to know perpendicular bisectors, that's where they intersect. We can conclude that PB equals PA, which equals PC. So those are some things that we can conclude based off of that theorem right there. Now we can start to apply that. Right here we have, one more theorem. So again, we have an angle bisector theorem. So if we have a point that's equidistant from an angle bisector, then it's equal, and we have DF equals FE. These are perpendicular here, and again, this is our angle bisector right here. And then the converse of it is, if you have these statements true, then we can conclude that BF is an angle bisector. So a lot of stuff, a lot of pictures. Let's try to apply that knowledge. So right here, we are given that find DB. They want you to find this. This right here means that we have an angle bisector. This is 5, so that is 5. Next slide here says find QS. We want to find this. This represents that we have an angle bisector. Set these two equal to each other. You can see that is done here. You find that x is 3. And once you find x is 3, we plug it into the original here. So 4 times 3 minus 1, 12 minus 1, QS equals 11. QS equals 11. So next concept here, they want us to find UV. Here's UV here. This right here tells us we have angle bisectors. We're going to set these two equal to each other. 3x minus 2 equals 4x minus 9. X equals 7. And then it says find the measure of UV. So to find the measure of UV, we're going to plug it in. So we're going to go 3 times 7 minus 2, 21 minus 2. Final answer is C19. C19. Next one right here, we have the angle bisectors meet at a point called the incenter. So what we want to do is make sure we have the 3 angle bisectors. No, these are angle bisectors. This is their connection point here. We can conclude that PD equals PE, which equals PF. So that's what we want to conclude based off of that given information. So a couple things. We know that if we know something is the incenter, then we know these are a combination of angle bisectors. So if this is 31, this is 31. This is 28, this is 28. So now what they want you to find is the measure of, they want you to find ST first, and then they'll find the angle second. So here we go, find ST. They want you to find this. So we have to look at side segments. So you have a 10 and you have an 8. What I've realized is some of you have not done the Pythagorean theorem. So if you have not done Pythagorean theorem, let me resketch. This is our 90-degree angle. This is 8. This is our x, which is what we want to find, and this is 10. So Pythagorean theorem is a squared plus b squared equals c squared. So in this case, you're going to go 8 squared plus x squared equals 10 squared. So again, now you can see where we're over here. 64 plus x squared equals 100. You subtract over, and you find that we have the square root of 36, and you find that x is 6. And you find that x is 6. So again, what you'd subtract 64, you have x squared equals 36. How do you undo a squared? You square root. So x is 6. So we just found that this is 6. So this is 6, and this is 6. So the final answer is 6. This one here now uses the angles that I was showing you in the previous slide, and I didn't really read the question. I guess I should have. We want to find the measure of angle SPU. This is SPU right here. So this is 31, this is 31. That's 28, that's 28. So what I do is I add this plus this. So 31 plus 31, so that's 62. And then I add the 28 plus 28, that's 56. Add those two together, that gives me a total of 118. I subtract that from 180. 180 minus that will give me 62. And then these are cut into 2 equal parts, so divided by 2. Final answer is 31. Final answer is 31 degrees. Same concept here. They want you to find the measure of GF. GF is right here. GF is right here. So what you have here is we are going to use the Pythagorean theorem. So I'm going to re-sketch my triangle here. And this is 5. This is 13. And we're just going to call that x. 5 squared plus x squared equals 13 squared. 25 plus x squared equals 169. We're going to subtract the 25. X squared equals 144. And then you take the square root of that. And our final answer is A, which is 12. Final answer there is 12. And now this one is one that involves the angle. So this is 35. This is 29. 35 plus, well, if you want to see, find the measure of BCD. They want this angle right here. 35 plus 35 is 70. 29 plus 29 is 58. Add these two together, we get 128. You get 180 minus 128, and that gives you 52. And then you divide that by 2, you get a final answer of 26. 26 degrees. Great job, folks. Hopefully this worked.